So first, to really talk about how the edge works in architecture, I'm going to send it over to Benson from Opto 22 to look at that piece of the architecture.
Great, thanks Travis. So I will be representing the edge of our architecture where we'll perform many tasks. But before I get into that, think about when you assemble an actual puzzle. Don't you usually start at the edge? We group all the edge of pieces, we assemble them, and then start filling in the rest of the puzzle. So metaphorically speaking, we'll take a similar approach here. First, we'll identify the assets and devices that make up our operations at the edge. Then we'll connect, collect, control, store, and even structure that data for use throughout our digital architecture. And we'll use Ignition at the edge to help achieve this. So for those of you who are unfamiliar with Opto 22, here's a little background. We are a California-based privately held manufacturer of industrial automation hardware and software with 5 decades of experience, an installed base in the millions at thousands of customers worldwide. And we're known for highly reliable, mission-critical, USA-made products backed by lifetime warranties. But what makes us unique is our engineering philosophy for combining rugged, reliable OT systems with open IT technologies into affordable and versatile products that save you time, money, and effort. But what problems are we trying to solve at the edge of our digital architecture? First and foremost, how do we simplify our edge-related systems? As depicted in the image here, there are a lot of pieces and parts stitched together to achieve a desired automation objective. And these pieces cross one or more organizational domains. In other words, both IT and OT domains. Moreover, many of these pieces weren't designed with security and data democratization in mind, and certainly not the notion of scale. So while newer edge technologies are entering the market to address these points, they tend to rely heavily on IT-based experts, which proves challenging for the boots on the ground OT folks. So how do we solve these problems? Well, again, start with devices on the edge. What if we could combine many of the function-specific devices in the top image into one edge device that's simpler, more secure, and manageable? Kind of like how the smartphone transformed the cellular phone market. I mean, think about all the function-specific gadgets you used to carry around that have been replaced by your smartphone. Your camera, your music player, your video player, your navigation, flashlight, email, the list goes on. So at the edge, we can simplify the OT toolset down to a single device, connect and protect the system and the brownfield devices connected to it using onboard cybersecurity technologies like accounts, certificates, firewalls, and even segmented networking. And then we use Ignition running at the edge to collect, process, and model all of that disparate device data into contextual user-defined data types, essentially creating the single source of truth. Then we'll securely publish that model data into the digital infrastructure using open technologies our next presenter will discuss, like MQTT Sparkplug and MQTT and Sparkplug. So wouldn't that be cool? So here's one such edge device you might consider, the Edge Programmable Industrial Controller, or EPIC for short. The Groov EPIC combines tons of functionality into a single OT manageable device. Like your smartphone, you can choose to use all the functionality EPIC offers or just the one suitable for your application. For example, you may not need the PLC or I/O functionality, but you do need a secure device that can connect, collect, model, and transmit contextual information quickly, securely, and efficiently. But most importantly, this device performs important gateway functions like segmenting your OT or trusted network from IT networks or business networks you may not trust, all the while blocking unauthorized access with its built-in firewall. And Groov EPIC was designed to be owned and managed by OT, while also IT approved for their networks and infrastructure. So here's an EPIC system architecture illustrating how we're connecting OT systems like brownfield devices and standard I/O at the bottom of the diagram to lots of onboard apps like Ignition Edge with CirrusLink modules, and then securely transmitting all the necessary OT data up into the digital infrastructure for consumption by a myriad of applications, notably Ignition Standard or Ignition Cloud Edition, SEPAsoft MES, or even Snowflake, and also directly to your mobile or computer-based devices. Another option is Groov Rio, a remote intelligent I/O device with most of the features of EPIC, including Ignition Edge and top-notch security features. And because Rio has 10 channels of software configurable I/O, like analog and discrete signals, both ins and outs, thermocouples, and much more, this device is perfectly suited for digitizing older equipment you want to connect to your digital infrastructure through standard I/O interfaces. We even have a version of Rio named Rio Emu, which stands for Energy Monitoring Unit. And check out the free Rio Emu resource on the Ignition Exchange, which makes integrating energy monitoring into Ignition dead simple. So we'll wrap up with the Groov Rio system architecture, which appears similar to the EPIC architecture. Same concepts, less expensive package, and ideal for smaller jobs with lower point counts. To learn more about Groov EPIC and Rio, I invite you to check out our solution partner page on Inductive Automation's website at the URL shown on this slide, or just go to IA's homepage, choose Partners, Solution Partners, and you'll find Opto there. Thank you all for attending and learning more about the Edge puzzle piece.